My name is Ashley, and I'm class of 2018, and I'm the project leader of the Lineless fishing team for DCT. So the Lineless fishing project works to remove the vertical lines from the water that come with crab pots. So when you're fishing for crabs or some other organism that lives on the ocean floor, fishermen commonly deploy pots that sit on the bottom and then have a vertical line that attaches to a buoy so that after the fishing is done, they can find that buoy and pull the trap up. But when these pots are deployed in high density, it creates a lot of obstacles for whales that are migrating through the area, and whales commonly get tangled in these vertical lines, and by getting tangled in the lines, they reduce their quality of life because they're dragging these pots with them or because they cause severe injury to themselves. So the main innovative component of our device will be an acoustic release system. This is the buoy that would be held underwater when the crab pot is being used but not ready to be pulled up. Via one end, it would be attached to the crab pot, held down by a magnet. So the idea behind it is that you'll have a hydrophone that looks like this, essentially a microphone for underwater. This box will be placed on the crab pot, and the fishermen on their boat will put some sort of transducer in the water and play a very specific frequency noise. And when this hydrophone picks up that noise, a magnet will cancel a magnetic field and cause the release of this box from a crab pot. When the magnet's released, it'll allow that buoy to float up to the top as the string unravels. And then when the buoy surfaces, the fishermen will be able to locate it and pull it up at that moment, as opposed to having the vertical line in the water the entire time that the pot's deployed. So we're currently in the prototyping phase. We met with some experts who are interested in the project. We have the support from DCT, so we have all of our materials here in Durham, and we've been meeting on a weekly basis, dividing up tasks and then coming together and putting them together into a single prototype. So the main technical issue for us at this stage is the hydrophone. Acoustic data and acoustic processing is stereotypically really tricky. And so we're working on that. We have a hydrophone with us, but it's a matter of getting the right connection and having the right processing unit to understand, like, what frequency noise are we hearing? Is this the noise from the boat that we actually want to hear, or is this a whale or a dolphin making a noise? The idea behind this is that if we can create sounds that are at some frequency that whales and dolphins do not communicate at, so that we're not masking their noise, and if we can play it at the minimal volume needed to reach whatever depth this hydrophone is deployed at, then that's all we're looking for. So yeah, I would say the biggest trick for us right now is getting that hydrophone to work, but we have a lot of technical knowledge on our team, a lot of electrical engineers and mechanical engineers, so I'm pretty confident that putting the pedal to the metal, I think we can get it working quite soon. I would say if we can come up with a prototype, which I'm confident that our team members are well equipped to do that by the end of the summer, then testing it in the field off the coast of Beaufort would be really cool. And I think just by doing this, coming up with a cheap way to use acoustic release and remove those vertical lines from the water will help hugely in the realm of whale entanglements. And it would be really cool as undergrads to make such a large impact in an environmental issue.